Hello guys, welcome back. So here we have another question on network theory from GATE 2015. In the circuit shown, the current I flowing through the 50 ohm resistor will be 0 if the value of capacitor in microfarad is dash. So we need to find the value of C such that the current flowing through this 50 ohm resistance is 0. So we need to think, when will this current be 0? So when, even in a normal circuit, when is the current 0? When there is an open circuit, right? So let's say if this part entirely becomes open circuit, what does open circuit mean? Your impedance is tending to infinity, right? Then we can say that the current I is 0. And why this total part, why not just this 1 millihenry and C? If this is infinity, then still there can be some current flowing through this. So we want the current entering here to be 0. Otherwise we can also take the full circuit, but it is simpler to just say this impedance is infinity, right? Because we anyway know that in series combination it is 50 ohm plus whatever this impedance plus this impedance. Anyway, these two are finite, and only chances the C can make this to go to infinity. So we'll just analyze that part. So let me call this as some j omega L. This is j omega L, and this is 1 by j omega C. And we want this Z to go to infinity. So can we find this Z equivalent? So what is this Z equivalent? So this together is j omega L plus 1 by j omega C. So this total is this in parallel with this. So j omega L in parallel with j omega L plus 1 by j omega C. So this is equal to j omega L into j omega L plus 1 by j omega C divided by j omega L plus j omega L plus 1 by j omega C. So this is equal to j omega L into j omega L plus 1 by j omega C divided by 2 j omega L plus 1 by j omega C. So if I were to simplify this, let's say multiply both numerator and denominator by j omega C. So then I'll get j omega L into this into j omega C is omega square LC plus 1, right? And this j into j will give me a minus term. Similarly here it will be 2 omega square LC plus 1, right? So my Z is equal to 1 minus omega square LC into j omega L divided by 1 minus 2 omega square LC. Now I want this to tend to infinity. What does this mean? This means that my denominator should go to 0. So when, for what value of C does this go to 0? So C should be equal to 1 by 2 omega square L. So what is omega here? Omega and L here. Where omega is given to be 5000 radian per second, and your L is 1 millihenry, right? So your C is 1 by 2 into 5 into 10 power 3 whole square into 1 millihenry. So this is 10 power minus 3. So it is 2 into 25 into 10 power 6 into 10 power minus 3. So this is equal to 1 by 50 into 10 power 3. So in terms of microfarad, it is 10 power 3 microfarad by 50. So it is 1000 by 50, which is equal to 20 microfarad. So for C equal to 20 microfarad, what you actually notice is there is no current drawn from the source, which means that the power delivered by this load, or power which is dissipated in the resistor, is going to be 0, and which is very interesting, right? And this condition is valid only at this particular frequency. So even if you go some frequency below or above, it is going to still take some current, right? So the answer to this is 20 microfarad. So guys, if you notice, this is our 100th question, and this is the 100th day also. So if you have been following this daily for 100 days, congrats to you, and hats off to your discipline and commitment. So I'll be ending this playlist with this last video, but I would like to take up network questions from your end. So you can reach out to me on either LinkedIn or Telegram, and you can post questions which you feel difficult to solve or challenging questions. So I'll be taking them up, maybe one question per day, and I'll be posting. So I hope this playlist helped you in strengthening your basics in network theory. So I wish you guys all the very best for everything to follow. Thank you. Bye bye. See you.